Hello everyone, I'm Parimala from the School of Computing and Electrical Engineering at IIT Mandi. In this webinar, I'll present our project titled Development of Energy Efficient Deep Learning Models Guided by Perceptual Models for Sustainable AI. This project is funded by ANRF under the scheme of Prime Minister Early Career Research Grant. In this talk, I'll briefly discuss the motivation behind the project, highlight some of our ongoing research, and explain how these efforts contribute to our long-term vision of sustainable AI. We all know that deep learning has made tremendous progress over the last decade, particularly with generative models and large language models. However, these advances come at a significant computational and environmental cost. Training and deploying large models requires substantial energy and computing resources. This motivates the central question of our project: can we reduce the computational cost of these models while maintaining their performance and visual quality? There are two major ways to improve the sustainability of deep learning models. One is during training by designing efficient architectures. The other is during deployment, where the pre-trained models are compressed using techniques such as pruning, quantization, and knowledge distillation. Our project focuses on the second direction because it provides the practical way to make foundational models more energy efficient. Let me briefly explain pruning. Pruning removes parameters that contribute little to the final output, thereby reducing the model size and computation. Structured pruning removes entire channels or filters and it is hardware efficient. Whereas unstructured pruning removes individual connections to create sparse models. Our objective is to improve the criterion used for deciding what should be pruned. Most existing pruning techniques rely on mathematical measures such as weight, magnitude, or activation statistics. Our idea is slightly different. We draw inspiration from neuroscience, where the human visual system processes complex scenes remarkably efficiently. We hypothesize that perceptual models can identify the parameters that truly influence human visual perception, enabling more effective pruning without compromising the visual quality. To achieve this, we introduce a perceptual quality module. Instead of relying purely on numerical metrics, this module estimates image quality in a manner that better aligns with human visual perception. It is inspired by computational models of the early visual cortex and provides the foundation for perceptually aware pruning. Using this perceptual quality measure, we compute the sensitivity of each network channel to, to perceived visual quality. Channels that have a stronger influence are retained, while the channels with little perceptual impact can be safely removed. Since this analysis is performed after training, it avoids the computational expense of retraining the entire module. Overall, the project has three objectives. First is to develop the perceptual quality assessment module. Second is to design a perceptually guided pruning framework for generative and vision language models. And finally, to demonstrate significant reductions in computational cost while maintaining perceptual fidelity. I'll now briefly present two ongoing research works that provide foundation for this project. The first is image quality assessment via selective editing. This addresses continual blind image quality assessment problem. The primary challenge here is catastrophic forgetting, where adapting a model to new distortions causes it to lose knowledge acquired from previous data sets. So our solution is selective editing. Rather than updating the entire vision transformer, we freeze the self-attention layers and modify only the task-specific feed-forward network parameters. A lightweight hypernetwork predicts exactly which parameters should be updated, making adaptation both efficient and scalable. The results demonstrate that our method achieves the highest average performance while modifying less than 30% of the feed forward network parameters. The second work focuses on no reference image quality assessment. Instead of relying completely on task specific supervision, We employ perceptually aligned embeddings that are learned directly from human similarity judgments. This allows the model to better capture perceptual image quality. Our architecture combines three complementary pre-trained vision transformers: Dino, Clip, and Open Clip models. Together, they capture structural, semantic, and color information. These backbones remain frozen in our framework, making the approach highly more efficient. We fuse the extracted features using a lightweight attention mechanism and incorporate positional embeddings interpolation. This enables the model to handle images of different resolution without additional training. These two research directions provide the building blocks for our ANRF project. Uh, Going forward, we will integrate the perceptual quality assessment directly into the model pruning so that generative models and vision language models can be compressed intelligently while preserving perceptual quality. Ultimately, this will contribute to more energy efficient AI systems. With that, I'll conclude my presentations. I sincerely thank the NRFs for supporting this work. Thank you.